Welcome to Northwest Aerospace News Live. I am Jennifer Ferrero, a writer for the magazine and your host. Thanks to our sponsor, Aerospace Vendors. In today's episode, we talk with John Davenport, who owns and operates CPK Metrology in Redmond, Washington. He has 30 years of experience in design, manufacturing, and metrology. Let's welcome today's guest, John. Welcome.
Good morning. Thank you so much for having me.
Good morning. We recently worked together on your marketing through Top Drawer Media, and I'm getting to know your business. Briefly, what is metrology and how does it impact aerospace and advanced manufacturing applications?
Excellent. Well, metrology really is the engineering science around how we define, how we measure, how we ensure that we're measuring properly through calibration, how we trace the standards through to NIST, which is a National Institute of Standards and Technology. So, for example, we have a couple different standards we'll use. We'll use the SAE, which is the inch system here in the United States, and then SI, which is the metric system. So it helps to define that. It also defines how we dimension a drawing, or nowadays a model, with what the basic dimensions are, or more advanced things like geometric dimensioning and tolerancing, how we define the dimensions. And the traceability of standards. So all this equipment that we'll talk about, one of the things that we do is we calibrate it. And we want to know for sure, is it measuring accurately, and how we trace that through standards. What makes it so important for any industry, but especially through aerospace, is the challenge that a lot of businesses now, they'll purchase their parts from vendors. So they may have ABC manufacturing and PDQ manufacturing making two parts. And they'll give them the drawings or the models, and they'll make the parts, and they're both correct. But when we get to the assembly line, we put them together and they don't mate. So something's got to happen. We got to measure it and say, well, both companies are saying that the measurements are correct. Well, this is why we have standards in measurement and machines to find out which part is good, which part is bad, or maybe is the drawing or the model bad. So that's basically metrology in a nutshell.
Great. Well, it sounds like it's really important for quality assurance and inspection in manufacturing. So it's good to learn a little about that. Well, I understand that you both sell and service metrology equipment. Let's talk first about equipment sales broadly. What are the offerings and how do they differ? And how does a company owner know what to buy?
Yeah, it's a great question. We offer a couple different things that I'll talk about, and customers may have very, very large parts. They could have very, very small parts. They could have parts that are machined in a metal, so they're very rigid or hard. They could be making something out of rubber, very soft material, which has its own characteristics and challenges. So, for example, let's talk about the really large parts. For large parts, this company here, LK Metrology, out of the United Kingdom, makes a machine called the CMM. It's a coordinate measurement machine. They can be relatively small. I have one that's actually in a crate that will go into this room here in the next couple of weeks. So it's a granite base and a gantry that runs on air bearings over the part. There's a cross beam, and the beam comes down. And on the tip is a little ruby tip, and it touches, and it actually measures the part. Also, you can see here, this is a laser head that can be put on, and that will measure the part, the whole 3D geometry of the part. Then we can compare that to the model. So for very big parts, the CMM is the solution. We have some installed down in Portland. These are 7-meter machines. So this is a piece of granite that's 23 feet long. It's about 10 feet wide, and for stability and rigidity, the granite is at least 5 feet thick. So it's a very, very large, stable piece. And you can put very, very large parts on that. So that's for big parts. For smaller parts, this little probing, the probe tip, it could be too large. So for that, I have this product here from a company called Optical Gauging Products. These are what we call multi-sensing. That has video, touch probe and lasers. And these can measure very, very small parts, even down to printed circuit board type things. So that's kind of the two families of parts or machines and the types of parts we can measure. So for example, if you have a very soft part, I can't touch it with a probe. So I can only use vision or maybe a laser. We call that non-contact. And both machines can do that, but have different types of sensors to do that. So that's the type of parts that we can measure.
So when a business is looking at improving or modernizing their inspection process, as your tagline references, then how do they know which of these machines to buy?
Yes, right. So again, it's about the type of material, the size, which features, and then of course I can help to make that decision. The picture right now that's set up on the screen is for measuring shafts. So maybe you're making turned round parts. So that's kind of specific to that. But that's really, and this one here is a CMM. This is the one that we have down in Portland to 7 meters, 23 feet. So that's kind of the mainstay, CMMs and the vision machines. And this is how we help them decide what type of machine is going to best fit their need.
Great. And I really like how you referenced the ruby tip, which serves as a probe, which we can also see in your logo behind you.
That's correct.
And that's that point of measurement that you're referencing. That's great.
That's right.
So once a company purchases metrology equipment, do you deliver it to the business and set it up? What does that look like?
Yeah, so after they purchase the equipment, a lot of this stuff is quite large and generally heavy, even the small machines. So they'll get delivered directly to the customer site. Depending on the size, we could have the factory folks come in and do the installation. So some of these things, like I mentioned down in Portland, they're quite large. So it takes a rigging company to place it. And then to come and do the calibration, it takes very sophisticated standards. Some of which I own and some of which would come from the manufacturer. So it just depends on the machine, but it gets shipped to the customer. We'll go in, we'll set it up, we'll calibrate, and then we'll start talking. Then we'll start with the training of the engineers and technicians.
Yeah, let's talk a little bit about that training. What does that look like? And you mentioned it's engineers, it's technicians. How do you go about training them on this equipment?
Yeah, so there's a number of different software packages available for the different type of equipment, and they're all a little bit different. They're similar, so you need to understand that the principles, but they're all a little bit different. So I do personally train on all of the software packages, and so we'll go in after the machine is all calibrated. We'll do the training. And then sometimes, for example, a technician or an engineer, maybe they move to a different department, maybe they go to a different company. So somebody else comes in to replace them, or maybe they're just going to increase their staff. So we'll go back in anytime they need help with training. I can also do some support. For example, I can remote in with software. I can do remote training. I can also help them with just programming. So maybe they're so busy and they have a need to get things done now. I can remote in and do programming, or I can go on site, write programs at their location. Or if they have a similar machine, I can write programs here at CPK and then email the program to the customer, so that there's multiple ways we can support with software.
Great. Well, it sounds like you have a lot of flexibility with the way that you can support your customers regarding the software, regarding retraining if needed, as they change staff, or maybe even the software is updated and you're coming back and showing them how to use that software. So that's good.
Yep.
Anything else about training that you'd like to add?
Well, one of the things that we do, not just equipment, it's about how you handle the data, right? So all these machines, they automatically spit out the results, if you will, from the measurement. And in the old days, we would take that, it might spit out on a printer and a piece of paper. Nobody wants to do that anymore. And then, or it would spit out into an Excel spreadsheet. But there's really more elegant, more graceful ways to do that and to get the statistics. So one of the products that we sell and service is software by ProLink, specifically QC Calc. So the machine spits out the data. It does all of the statistics automatically. So the CPK is really the acronym for capability, process capability. And that's a very important number that operations, the plant manager wants to know that. They want to know how capable is this process. They want to be able to predict through a risk assessment and through the data, what's the likelihood I'm going to be making good parts, how many failures I'm going to have. And this really defines how many parts you have to measure. Let's say you make 100 parts a day. Do I have to measure all 100 parts? Or can I statistically say, no, I can measure 10 and have a high probability. So this software helps to do that busy work. In the old days, we'd get the data, I get into Minitab, I put the data in and manipulate it, look for the CPK, the capability number, and other things. And that's really just busy work. Nowadays, we have software to help handle all of that and really help the engineers focus on more important work, if you will.
Great. Well, it sounds like it is all important work. So I'm glad that you elaborated a bit there. What ongoing maintenance is required for businesses to ensure proper function?
Yeah, so most metrology equipment has an annual calibration interval, meaning that they suggest that every year it needs to be calibrated. So what we do, and this is all part of the ISO and NIST, is we'll calibrate the equipment. So I'll come in with what we call a standard. For the vision machines, it's a piece of glass with multiple intersections. And then I have a table that defines exactly where these intersections are. So I'll put the glass down on the machine, I'll measure the intersections, and it will tell me, is the machine measuring accurately or is it out, right? And that's the as found. Calibrate. We'll make those corrections so that when I leave, the machine is measuring accurately according to the manufacturer's standards, right? The CMMs, the big machines, they have very, very large standards to measure in 3D volumetric calibration. So this is a process that we provide. This is part of my ISO certification at CPK. I'm ISO certified to do calibrations and also to do inspection work. So we can talk a little bit about that in a minute, but this is all the ISO stuff that we can help the customer to make sure that their machines are measuring properly.
Great. Well, finally, let's talk a little bit more about metrology regulations and other quality assurance certifications. You've alluded to that, but tell me a little bit more about that and why it's important.
Yeah, so really it's important because nobody wants to be making bad parts. And the only way to ensure that is to measure. And if you're going to measure, the question is the machine measuring properly? So that's the kind of the question that happens. So you're at ABC Manufacturing and everything's been hunky-dory. And then suddenly the quality department is saying, hey, these parts are bad. And manufacturing says, well, maybe the machine's bad. Okay, well, that's where the calibration comes in. This is where standards. So for example, this is just a simple one. This is what I tell customers to do. This is just a 4-inch gauge block. So the dimension here is 4 inches. It's not exact because nothing is, but I don't need to know. It doesn't have to be exactly 4. What I need to know is what is the actual dimension. So this, I get a certification from this that tells me the exact dimension. And every 5 years, I need to send this to a lab better than my own, which is also certified by NIST, and they measure it and they give me a report. And then, of course, I can see over time that it really hasn't been drifting, but I need that for my ISO certification. So then I'll take this to the customer and they'll say, hey, the machine's not running right. Well, okay, let's find out. We'll put the standard on the machine, we'll measure it, and then we'll find out, is it measuring properly or not? So I recommend to customers, if they want to know, is the machine drifting over time? Is it good? Get yourself some standards, measure it on the machine, save that data, put the standard in a little velvet bag in the bottom of your dresser drawer. And if you think the machine's not measuring properly, get that out, measure it, and compare the results. But put the standard someplace safe. And that's really the whole idea behind the traceability. Is you would trace it all the way back to the standards, the gold standards, so that we can ensure that the machines are measuring accurately.
Great. Well, John, this has been really informative information today. I thank you for your time to talk about everything. Thank you for coming on the show.
Yeah, my pleasure. Thank you so much.
Well, if you want to learn more about John, you can visit his website at cpkmetrology.com. Thank you again to our sponsor, Aerospace Vendors. Until next time, keep engaging with the aerospace and manufacturing news you need to know in the Northwest with Northwest Aerospace News Magazine. Goodbye.